Welcome to Schweitzer Drive, a podcast where we explore what goes on between the generation of electricity and the light switch. Join Dave Whitehead as he interviews the entrepreneurs, innovators, and experts who are inventing the future of electric power.
Hi, I'm Dave Whitehead, CEO at Schweitzer Engineering Laboratories, and today we have Phil O'Reilly, VP Global Head of Enterprise at Juniper Networks, and we're going to talk about IT and OT. But quickly, some background on Phil. Phil drives worldwide integration of all routers to market for Juniper's networking and security solutions. He's created a seamless program that maximizes customer impact and resource efficiency while maintaining alignment with sales and product strategies. And here's something I didn't know about Phil, that he is not, maybe correct me if I'm wrong, Phil, not an electrical engineer, rather you're a lawyer.
Well, actually, I'm also a master's in mathematics too, Dave, so that's kind of my thing, numbers.
How the hell did you end up doing networks?
Yeah, well, I fell and hit my head and actually woke up and realized lawyering was not what I was good at.
That's awesome. I also see you're a military-trained commercial pilot, and you're active in search and rescue activities with the Civil Air Patrol. I'm sure that's in South Carolina?
Yes, sir. In Charleston, South Carolina, I was both in the Navy and flew in the Air Force in the reserves. I've been flying since I was 12 years old, started in Texas in gliders, and to this day, it's still a real passion for me. And I sure learn a lot of life lessons flying an airplane, and I try to apply them every day if I can.
Yeah, I guess you either learn those lessons or you have a really bad day when it comes to flying airplanes.
That's right. It rewards preparation and caution. There's an expression, they're old pilots and they're bold pilots, but there aren't too many old, bold pilots.
Well, thank you again for joining us. I've been really looking forward to having this conversation. Certainly in our industry, the electric sector, there has been, as long as I can remember, I'll call it a divide between the IT and the OT. And I like to think I have a pretty good handle on both, or at least enough to appreciate both sides. I can remember going into some conversations with the IT and the OT folks and feeling as if I was a therapist for the meeting, trying to explain each other's side. But how about we start off? Would you tell us a little bit about your role at Juniper and some of the challenges you're looking to solve these days?
Sure, Dave. So I do run the enterprise team globally. That's a new role for Juniper. The company is beginning to realize more and more how interconnected everything is. We used to operate pretty much in geographies, but now we've normalized things global model. That gives me some advantages in terms of the ability to see things from the broadest perspective. And challenges, well, like any IT company, we're making our own transition. In the past, it was all about the physical platforms, routers, switches, firewalls, you name it, hooking them together. More and more, software is playing a significant role in the deliverable, and we're moving away from the physicality of the environments and moving more towards a dynamic ability to deliver an outcome, particularly to an end user, whether that's the industrial customer or whether it's an actual end user. COVID has certainly brought that to the front. It becomes more and more important. And so I'm trying to change the mindset from a modular or a platform thought process to a turnkey end-to-end deliverable process, and get our salespeople to engage our customers in those conversations. It's been rewarding, but I'm not going to lie, it's also been quite challenging.
Yeah, you made an interesting point that things are not regional anymore. You said you organized by parts of the world before, but now it's more of a global sales, and that's probably the way things are headed these days, right? I gotta believe engineers sit in one part of the world, they get the systems get deployed in another part of the world. The whole sales, support, design concept has to be really, really challenging, especially for a company like Juniper.
Yes, it is. It's quite challenging. And of course, our customers are exactly the same. They're hyper distributed from that point of view. So not only do their needs vary, but we have to establish this baseline of, well, what's the common requirement? And then what's the ability to create and serve the local needs. And that's true of any place in the world. And the problem is you can't deploy unique systems in all those environments. And hence this movement to an underlay and an overlay, abstracting capabilities, particularly with regard to telemetry and assurance and all those things. That's where the software comes into play. It's so much more a part of it than it was before. So we're about now 60% software engineers and 40% hardware engineers. And in the past, it was about 80-20 in the opposite. So it's also a new set of skills that our own internal development teams are starting to learn. But that's where our customers are going, and we have to follow them.
Hey, Phil, real quick before we jump into the rest of the stuff, you mentioned COVID just a little bit. I would imagine, well, I won't imagine. What did you guys discover with COVID, both at the Juniper side and at a customer side? Were there any aha or profound moments as a result of COVID?
Well, it's an interesting question, Dave. It makes a comfortable chair important. That's the first thing I learned. But really fundamentally, you realize that life and business go on, Dave, and you got to find new ways to address your customers' needs in the virtual environment that we were forced into. It really put a premium on kind of eating our own dog food, delivering the capabilities that we promise our customers to ourselves and to them, not only in terms of the outcome, but also in terms of, frankly, just interacting with them. So all of the new technologies, which rely on connectivity and infrastructure, they all take advantage of where we're going with the kind of the model that we're pursuing. And so I'd say that was probably our key learning, that technology properly designed, properly deployed, gives you the capability to have intimacy, which is really important, in dealing with your customers, and to have scale, and to have the flexibility to address situations that, frankly, even 6 months ago, we might not have even imagined. I think all those characteristics, frankly, also apply to the business that you're in, if I'm not incorrect.
Yeah, you're right. You brought up the every organization was presented with let's call it a new opportunity as it relates to COVID and how we're going to support customers and run business. There's a quote attributed to Ron Emanuel, the chief of staff for Obama during his first term. And it goes something to the effect of never let a crisis go to waste. And people usually cut off that statement right there. And it kind of sounds, like Ron was trying to take advantage of a particular situation. But what fails to get reported is the rest of his statement, where it says, never let a crisis go to waste, because it allows you to try things you might never, ever try under normal circumstances, right? And it's really a powerful statement. And I think a lot of us, certainly Juniper and SEL and many of our customers and what have you, have taken the opportunity to try things we would just never, ever have tried before, because essentially we had to, right? The world changed at one point, and we all needed to adapt.
Absolutely.
All right. So Juniper comes to networking from the IT side, and SEL, we come from the OT side. How would you define IT and OT in both terms of technology and maybe even profession?
So it's a great question. Of course, I'm pretty much been around since Moses was a child. So I remember the OT days, and I thought of OT as kind of a set of hardware and software that was designed to control physical devices, monitor and control them. I come from the old SCADA days. My first programming experience was programmable logic controllers. So back in the day, when OT was, frankly, functioned a bit in a self-contained and unrelated, sort of independent environment. IT, on the other hand, has always been about data transport, about data analysis, about data scale, storage, and how that data is being used. So the application world is, frankly, ultimately related just to data. So you think they're separate, and in the past they used to be separate. I think a lot of people still think of them as separate. But to be perfectly honest with you, Dave, I actually think they're more highly correlated than we really give credit to. At the end of the day, they're both about data. They're both about doing something with the data. In the case of OT, it's to drive devices. But when you do that, the devices actually create data in response. So OT is now much more bi-directional than it used to be. IT is about taking that data, usually really agnostic as to what the data is or where it comes from, and just simply applying a set of rules or applications or analytics to it as well. So, why wouldn't I use that same paradigm against this data set that's being created on the OT side? So, the marriage of those two actually creates, I think, a hyper dynamic opportunity for us, not only in terms of scale, but also in terms of simplification and in terms of adaptability in a way that in the old days would have required a significant investment of time and, frankly, money to physically change the old SCADA environments or these control environments that we had. You know, frankly, even the industry recognizes this convergence because we don't talk about IT or OT anymore. What do we talk about these days? IoT. So it's the Internet of Things, the thing side being what I used to think of as OT, and the I side being the systems that manage, scale the data associated with the two. So I think there's a marriage been made. And I think that the industry is slowly coming to recognize that it's not a threat, it's actually an opportunity.
Yeah, I really agree with you. I think from my perspective, maybe I'm a little bit too hardware centric because I grew up as a hardware engineer. But on the OT side, I look at it as the communication part of a control system. So to me, data availability and reliability are paramount to anything. And I look at the IT side, which is they have the probably the biggest problem I could ever think of, but kind of this idea where all things, the ease of use of a network and how to all data flow through it and manage it with printers jumping on or my iPhone jumping on and getting data to where it needs to be, where speed or determinism probably isn't the most important thing. It's that connectivity where all things can get to different places. And what I think is happening too, probably along your lines, is there is this convergence. There's good in both of those worlds, and making sure the IT guys and the OT guys understand and respect challenges of each one of them, and then taking the best. Because I think if we just applied IT rules to the OT systems, they're going to break, and we'd never get your email if we applied all the OT rules to IT systems. Or certainly we get Netflix.
That is correct. Absolutely. So you're absolutely spot on. I think, though, the key here is to take advantage of what's available in both systems and combine them. There's not a requirement to say, oh, we have to abandon one or the other. They can't operate without each other. They can clearly interoperate. There's no doubt about that. And they can take advantage of the strengths of the two. So the whole idea of dynamism in a network, rather than building a custom built, purpose built, bespoke solution for a particular industrial environment, I can build a simpler model with a set of abstracted capabilities that not only can apply to this place, but that place as well. And as I then look at all of these individual environments, I can create a level above where I can correlate in a much easier, much straightforward way. The other thing that I think IT brings to OT is, in the past, Dave, my experience with OT was it was locked down for a lot of reasons, but one of the primary ones was the potential security ramifications of opening them in any way. And the ability to apply IT capabilities for the monitoring, for looking for network changes, for creating some very, very deterministic sets of rules and transaction paths, identification, a perfect model of the infrastructure allows IT to offer a level of security that in the past was very difficult to deliver in OT environments.
Yeah, and I look at to your point, OT is locked down. The other reason I think it gets locked down is because it's usually part of a control system. And once you got your process up and running, you don't want anybody messing with it. Unlike the IT environment where, like we said, users are jumping on and off networks all the time. You need to data is different throughout the network, so it offers some interesting opportunities and challenges. Where do you see the commonality between IT and OT and perhaps some of the gaps?
Well, so you'd think they're real different. I mean, I'm sure you could care less about the capabilities of a 400 gig interface And most people on the IT side wouldn't have a whole lot of sensitivity to traveling weight, fault, location, capacity. So you would think that they simply don't talk to one another. But you know what we have in common? We have this need to communicate, both IT providing it and to securing it and to monitoring it, and OT doing exactly the same thing. So I think the convergence and kind of the commonality is around finding a simple, secure, reliable communications infrastructure that's applied to hypercritical environments, even life safety environments. You know, the military is a great example, Dave. We have real-time battlefield networks that have a requirement to operate that's extremely high. And the consequences of the failure of that network is that, frankly, somebody's likely to die. Well, those are pretty high stakes. This is not a matter of losing $12 in somebody's bank account, right? Well, I think of infrastructure, particularly electric utility infrastructure, electric companies, water companies, etc., that serve pretty much the same life critical need. They have this demand on them. I mean, unfortunately, all you have to do is look at what happened in Texas, last week and over that period of time. So the ability to deliver that reliability, that scale, that flexibility, and that intelligence to these networks, I think creates a new opportunity for OT. I really think that's where the convergence is. And really, if we do this right, 1 + 1 can equal 3. Because while OT systems are by their nature, as you said correctly, locked down, as they operate, by keeping track of how they operate over a period of time, we can use IT tools and artificial intelligence and all of these capabilities that have evolved pretty dramatically to give you, the operator, the ability to even refine those lockdown systems, make them operate more efficiently, make them operate at a lower cost, make them operate more securely. All those capabilities come from the combination of OT and IT, I think.
So that's interesting, and which is going to lead me on to my next question for you. You and I have talked about this IT and OT convergence, and it's obviously it's a hot topic. What value do you see for convergence of IT and OT that brings to customers and industry? And then maybe a counter question to that is, do we need convergence at all? You brought up IoT, right? Which it sometimes I think of it's the Internet of Targets as opposed to the Internet of Things. My wife remodeled our kitchen, and I can now use my iPhone to turn on my oven, and my refrigerator. It can tell me how cold it is in the freezer. So just because you can do something, does that mean we should be doing it? There's some risk and reward for everything we ever do.
You are absolutely spot on, Dave. I mean, you got to ask the why question. Like, why do I want to do this, even though I can do it? So, I actually think there is huge value here. It comes into a couple areas. I mean, one, the most prosaic, but still fairly important, is the cost aspect, right? By applying IT to OT, particularly in power systems and power grids, DERs are becoming more and more common. So this ability to manage on a grid scale, IT can really increase efficiency, primarily through simplification. So I do believe that reduction of complexity lowers cost and allows you to operate systems, for example, with fewer people. It requires fewer people to make changes in the network because you can automate that to a very, very high degree. So I think that's probably one reason why we should be looking at that. The second is resilience, redundancy. And the problem with an OT system in many cases is it's point-to-point, monolithic. It delivers. It's expensive and somewhat difficult to build redundancy into that system. But if you're using a system which by nature is redundant, and the best example I can give you is the internet itself. The resiliency and the redundancy of the internet is based on this multi-point capability, this ability to find alternative paths when necessary, and to have intelligence that makes that decision when it becomes critical. That's really an important capability that IT can offer, I think, to OT in this case. And I think that there's a lot of ways that manifests it. clearly this project that we worked on together, Project Ambassador, funded by the DOE, and now we have a commercialized version of it, this converged industrial edge product. We've proven that, in fact, we can deliver cost reduction, we can deliver resilience, and we can deliver redundancy. We can also deliver a new kind of security into these environments. Yeah, Internet of Targets is absolutely true. But if you're using a really intelligent control environment that's taking a look at all these inputs, it can really, in a much more discrete way, control access to the network and can isolate bad actors through behavioral analysis much faster than we could in the old days. So huge advancement in security. And then the last thing that I see relative to the marriage of these two technologies is innovation, Dave. You know, OT systems have been around for a long time. I mean, literally since the beginning of the Industrial Revolution when it comes down to it. But with the pace of change that's going on, we're finding new and better ways to apply these systems to solve problems in a way that we never could before. If we have to build them each from scratch, it becomes a very difficult, very expensive, very time-consuming process. With IT systems applied into OT environments, we have the ability to experiment and iterate very rapidly because it's software. It doesn't have a physical presence necessarily, and we can test improvements. In fact, we can even automate the testing of those improvements. And as new things happen, new power sources, for example, come into the grid. I think of wind power and I think of hydroelectric or solar, or even now the need to create these giant battery storage capabilities, which has been talked about a lot in Texas over the past couple of weeks. All of these new modalities will probably require a different interface, set of controls, set of visibility. By using IT to do that, we can probably innovate a lot more flexibly and a lot faster.
We just talked then about the convergence of IT and OT. What are your thoughts then about still perhaps keeping, I don't want to call them two separate networks, but they're going to converge at some point. But still in my mind's eye, if you will, the OT, or at least the control portion of it, the real-time control, should probably be a standalone OT network, probably leveraging some IT, capabilities and things like that. And
yes.
I can see more of an IT side, perhaps some cloud computing on, say, the optimization of power system, where it's not critical real-time, rather, as you pointed out, some AI, maybe some machine learning, something of that nature to really smooth out the grid or do optimal power flow, or where efficiencies can be gained, or economic dispatch, those kind of things. Do you think we should still have a separation of some sort between at least some part of the OT networks to IT?
So my short answer is yes. And you wouldn't think an IT guy would say that, but let me explain to you why I say that. So what you're actually talking about is actually the model that created the modern IT infrastructure that we currently see. Back in the day, it was one device and it did everything. It managed all of the flows, and it also did all the traffic, transited all of the packets, for example, or the sessions or whatever it was managing. So back in 1996, the founder of Juniper, Pradeep Sindhu, came up with this crazy idea. What happens if I separate management from the actual traffic flow, the packet transfer? If I split those two into separate planes, does it create an advantage? And the answer was a resounding absolutely yes, because I was able now to allow traffic to be optimized on the transit plane and yet controlled, visualized, and managed through a separate set of functionality. They weren't one and the same. So I think what you're suggesting, Dave, is a really good idea. The OT pure infrastructure, which has certain characteristics, particularly with regard to timing and stability, jitter and latency are absolutely deadly in timing environments. As a mathematician, I understand what a mistiming of entering a grid from a phase differential, the difference that will actually take the grid down, to me is mind-blowing, that we can actually control that using the OT systems that we have. Not only can we have to. But what I think of the IT plane now as essentially this management, automation, visualization capability that serves the functions that we talked about, flexibility, innovation, security, scale. All of these things are delivered by the IT overlay, as it were, against an OT underlay. And to a great extent, a lot of the IoT deployments that are being occurring, particularly in commercial environments, are following that same model. IT operating as the overlay, and the physical systems and the SCADA environments that control them operate with a degree of independence underneath. So I think it's a good model. Ultimately, I think we will move to a more IT oriented model as people get comfortable, particularly with the cloud. But for the time being, I think that's an excellent way to proceed.
So really, Juniper was doing software-defined networking before software-defined networking was cool.
You bet. I mean, I tell people this all the time. The only difference between a router and a switch, which people think of as completely different devices, is the management software, Dave.
Yeah.
The forwarding plane is exactly the same. It's all just packets that's flowing through there. What I do with them is controlled by the intelligence in the device, and I can abstract that. And of course, now I've gone way beyond putting it in an operating system and taken it all the way out and created this actually completely isolated overlay. Actually, OT is moving in that direction as well. We're creating common control systems at the absolute baseline, what you might consider layer 0. And then we're abstracting certain of the control functionality 1 or 2 layers above it. In fact, as I understand SEL, you guys are the absolute world-class leaders in that process.
Well, I don't want to be too boastful, but we certainly enjoy working in that space. Hey, Phil, if I could ask you, call me just an old OT guy. What would you say, or how would you respond to an OT guy and tell us what we should be thinking about from a cybersecurity and network communication standpoint? How do you think we could elevate or advance our state of the art?
Yeah, I guess I could capture it in one phrase, Dave. I'd sure like to teach some old dogs some new tricks. I mean, really, when it comes down to it, there's I think a natural anxiety and maybe potentially some confusion, because in the past, the people in this industry have really seen these as two separate worlds, and they do their own thing, but integrating them created what was perceived as some risk. I kind of wish I could set that aside. And I'm not asking people to wholesale say, yeah, this is great, let's just try it. But I'm asking them to be curious and to look at some of the things like Project Ambassador, this project that we so successfully built together. Just take a look at it. Understand that it's fully approved. It's been vetted and tested in multiple environments. It does offer some very specific advantages to the service providers, and to the people that would be interested in these systems. I would ask them to just have some curiosity about leveraging these technologies. I would also ask them to think beyond what it is that they have historically been responsible for, because I live in South Carolina, and I'm in IT, and I have to be honest with you, I worry about the vulnerability of our power grid and our water control environments. In fact, all of those environments, even the traffic light environment, there are multiple industrial applications for what we're talking about, both what SEL does and what Juniper does. And I'm worried about that. I think sometimes in the old OT school, because it was so isolated, there was less sensitivity to the really profound security risk. And so I'd sort of like them to start to get a little bit more attuned to cybersecurity and some of the risks that are created and some of the ways that IT can help OT resolve those issues.
Bill, I think you're spot on, especially about your comment about the experimentation, test, try out new ideas. I think that's really what's going to push our industry and all the OT industries forward to be safer, more reliable, more secure, better for our country, better for our customers. I think it's an exciting time. There's a lot of cool technology. You talked about Ambassador. The SDN, I think, is so perfect for OT environments. I think there's a lot for all of us to sit back, learn, scratch our heads, and figure out how to take new ideas and solve our problems.
Agreed, 100%, Dave. I couldn't agree more. And I think America's leading the way, and I'm proud to be part of it.
Amen. All right, Phil, this is a great conversation. I appreciate you taking some time out of your day to talk about IT and OT.
Dave, it's always a pleasure to talk to you, man, and anytime. And let's keep working on things together because, like I say, with what SEL has created and what Juniper is contributing as well, I think we've got an entire world of industrial control systems where what we're developing here can be applied to the benefit of all.
Well, Phil, I'm going to mark you down for a year from now. We can see where we've come over the next year.
Sounds good, Dave.
All right.
Listen, y'all take care, and I'll talk to you soon.
Okay. Bye-bye.
All right. Bye-bye.
Thank you for stopping by Schweitzer Drive. Join us again as we learn about, explore, and celebrate electric power. For more information about the show, please visit selinc.com/Schweitzer Drive.